All right, today we're going to deal with Boolean algebra's version of the distributive property. Now, I've got a big, nasty truth table behind me. Be calm. The reason it's so nasty is whenever you're dealing with 3 events, there's 8 total possibilities. 2 times 2 times 2. So these are all of the possibilities. True, 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 all the way down to false, false, false. Okay? But our purpose in looking at this truth table, we're very interested in this statement right here. P and Q or R. The parentheses are necessary. Ands come before ors in Boolean algebra. So if we didn't say anything, this would go first, and then we would look at this, and that's not what we're wanting here. So what I've done is I've gone ahead and given us Q or R. So Q or R is going to be true if either Q or R is true. So anytime that Q is true, we got a true. Anytime R is true, we got a true. Basically, the only time we didn't was when they were both false. Okay, so of those 8, only these 2 were false because that's when they were both false. So P and Q or R. Now, this is an and, so we need P to be true. So if P is false, we're already hosed. So these bottom 4 aren't going to cut it for us. Okay, make that a little darker. So if P is true, now we need Q or R to be true. In this case, they're both true, so the or will be true. The or was true here. The or was true here. But here, Q and R were both false. So we get a false there. Okay, this should kind of make sense. So P and Q or R. So only the places where these were true and these were true is where we got our trues right there. But I'd like an opportunity to rewrite this. Okay, so what I've done, let's ignore this part of our truth table. What I've done is I've split this up into 2 different and statements here. I want to see if you notice anything. So here is P and Q. Okay, it's true here, false everywhere else. P and R, it's true these 2 places and false everywhere else. So I wonder what these 2 have to do with this. Well, it looks like if these are both false, this guy is false. Every time we get double false, we get a false over here. But as long as there's at least 1 true, we get a true over here. Well, that sounds familiar. Okay, if we're only getting false if they're both false, otherwise we're getting true, that's an or statement. So this is equivalent to this or this. Let me write that out. So P and Q or P and R. We don't technically need those parentheses, but that makes it a little clear. We're dealing with these first, and then there's the or there. So you can kind of see we're distributing our P and into both parts there. That's why we kind of call this the distributive property. Okay. I'm not going to show you the truth tables on the other one, but there is a similar property for or. Where you're distributing or into and. So if you're distributing or into and, the same thing winds up happening here. It's P or Q and P or R. So we wind up with basically this distributed version. And it's important to note that you can have this property work backwards. So if you have P and Q or P and R, we can rewrite it as, we can kind of factor out the P and. Can you dig that? Okay. P and Q or R. Okay, so that Boolean algebra works both ways. So this is the distributive property. I would memorize this because this is going to make some of your multiple choice problems much easier on the AP test. So again, we can distribute and into or. We can distribute or into and.